Assalamualaikum, my name is TENGKU NAZRAN bin TENGKU AZREE, and today I will be presenting on the topic of approximate estimating in construction. Now, for the introduction. Approximate estimating is a method used to determine the initial or preliminary cost of a construction project when only limited design information is available. It is typically applied in early stages of planning and feasibility studies, where the full specification, working drawings, and bills of quantities are not yet complete. Approximate estimating is important because it helps client and consultant decide whether to proceed with a project. It also allows comparison between design options before detailed planning takes place, especially when evaluating different layouts, sizes, or construction methods. Additionally, it aids in budget allocation and cost control during early discussions and feasibility reviews, and it supports standards, planning, and financial forecasting, helping consultants and developers prepare for future procurement steps. At the early stage of a project, approximate estimating serves several important purposes. First, it is used for planning approval, investment appraisal, and loan applications. These early estimates provide financial figures that can support submissions to local authorities or financial institutions, giving them enough confidence to consider approvals or funding. Second, it quickly establishes whether a project is financially viable. Without going deep into technical drawings, this method can still provide a ballpark figure allowing stakeholders to judge if the project can proceed within the available budget. And third, it enables early-stage decision-making without needing full construction details. This means key choices like choosing between different designs or deciding when to start can be made faster, reducing delays in project lifecycle.
After that, methods of approximate estimating.
Several common methods used for approximate estimating in construction. Each method serves a specific purpose depending on the available information at the type of building. The first method is the floor area method, where the total floor area of the building is multiplied by cost rate per square meter. This method is commonly used in residential construction. For example, if a daycare center has a built-up area of 250 square meters and the cost rate is 950 ringgit per square meter, the estimated total cost will be 237,500 ringgit. The second method is the unit method, which estimates cost based on the number of units. This is often used for housing projects or schools. For instance, if a housing development consists of 10 identical units and each costs 180,000 ringgit, the total estimated cost is 1.8 million ringgit. The third method is the cubic content method. It calculates the total volume of building in cubic meters and multiplied by a unit rate. For example, if a warehouse has a floor area of 500 square meters and a height of 4 meters, the total volume is 2,000 cubic meters. At 300 ringgit per cubic meter, the estimated cost would be 1.2 million ringgit. Lastly, the story enclosure method is used for multi-story or institutional building. The enclosed volume of each story is calculated by multiplied by a unit rate. For example, if one story enclosed 1,200 cubic meters and the rate is 750 ringgit and the estimated will be 900,000 ringgit. Each of these methods serve a different type of project and depends on how much information is available during the planning stage.
Advantages and limitations of this method.
Starting with the unit method, this technique is very quick and simple to apply. It is especially suitable for early budgeting in repetitive building projects, such as terrace house or apartment blocks where each unit is identical, because it only requires multiplying the number of units by a standard cost per unit. It is effective for rapid assessment. However, the unit method comes with significant limitations. It doesn't account for design complexity, material quality, finishes, or external works like fencing and drainage. This lack of detail can result in underestimation and overestimation, especially for non-standard units. Next is floor area method, which offers more accuracy than the unit methods. It works particularly well with standard floor plans, such as bungalows or semi-detached house, where the total built-up area is already known. It allows for a better reflection of size and general layout in estimate. That said, the floor area method also has its drawbacks. It often ignores external works and site-specific challenges like sloping, land, or soil conditions. Additionally, the cost rate per square meter can vary depending on material use, finishes, and quality standards, which introduce a level of uncertainty if not adjusted carefully. Now we move to the cubic method, which is useful for projects where the building height significantly affects costs, such as warehouse, halls, or showrooms. By considering the total building volume, it gives a better sense of cost for volume-based structures.
But the cubic method also has limitation. It's difficult to apply without a more detailed design because it depends on accurate building height and wall type thickness. For simple low-rise homes like single-story bungalows, this method tends to be less appropriate and unnecessarily complicated. Finally, we have the story enclosure method. This method is more comprehensive and works well for high-rise or complex institutional buildings. It is considered surface area and different story volumes, making it more technical, precise in large-scale developments. However, its limitations include the need for detailed design data and measurements, which are usually not available in the early stage. It's also not ideal for a simple residential building like the single-story bungalow we are estimating in this project, as it would be too detailed for what is required.
Application to a project scenario. On to the topic application to a project scenario. The project involves a purpose one-story residential bungalow house located on lot 19176 section 69 in Kutong Lebat, Kota Baru, Kelantan. The building has a rectangular footprint with overall dimension of 14.85 meters in length and 11.50 meters in width. This gives a total build-up area of 170.78 square meters based on the architectural plan provided. The cost estimate is prepared using the floor area method based on local market rates suitable for residential housing in Kelantan. After that is selected estimating method, which is the floor area method due to its suitability with the current stage and nature of the project. There are 6 specific reasons why this method is appropriate. First, the project is at early stage of development during which full bills of quantities or tender documents have not been prepared. The floor area method enables a quick and reasonably accurate estimate using basic design input. Second, the building features a simple and straightforward single-story design. The rectangular layout and absence of complex forms make it ideal for area-based cost calculations. Third, the total build-up area is already known from the architectural plan. With an external dimension of 14.85 meters by 11.50 meters, the total area is 170.78 square meters, which fits perfectly with requirements of this method. 4. Reliable local construction rates are available. The rate of 942 ringgit per square meters was selected based on market data for a similar residential building in Kelantan, allowing for realistic and defendable cost estimate. Fifth, the estimate concern a single unit only, not a larger development. This makes the floor area method more efficient compared to detailed trade-based or elemental methods, which are more suitable for complex or multi-unit projects. And 6, the method supports early stage budget planning and feasibility analysis. It helps stakeholders set preliminary cost targets, explore design options, and prepare for further approval or funding application. Next is rate breakdown based on building design. The rate applied in this estimate is 942 per square meter ringgit based on current market prices for typical single-story residential construction in Kelantan. This figure represents the sum of all major construction components. The substructure accounts for approximately 121 ringgit per square meters, which includes foundation works such as excavation, footing, and ground beams. The superstructure consisting of brick walls, reinforced concrete columns, and suspended slabs contribute around 182 ringgit per square meters. Roofing, including trusses and concrete roof tiles, is estimated at 160 ringgit per square meters. Finishes such as floor tiles, plastering, and ceiling work contribute a further 230 ringgit per square meter. Openings, including timber doors and aluminium windows, are located at 70 ringgit per square meters. Plumbing and electrical installation, including piping, sanitary fittings, and wiring, at another 68 ringgit per square meters. Finally, 81 ringgit per square meters is allocated to preliminaries and miscellaneous items like temporary works and site facilities. Altogether, these components form a comprehensive rate of 942 ringgit per square meter, which is then applied to the total build-up area for the final cost estimation. For final calculation, the use of the floor area method will apply to estimate the total construction cost by multiplying the building's total build-up area by standard construction grade per square meter. This technique is widely applied during the early design phase, particularly when full construction details and bills of quantities are not yet available. For this project, the floor area is derived directly from the approved architectural plan. The external length of the proposed bungalow measures 14.85 meters and the width is 11.50 meters, resulting in total build-up area of 170.78 square meters. This figure includes all internal spaces, external walls, and the front porch, representing the gross build-up area used in the cost calculation. The unit rate applied is 942 ringgit per square meters based on recent market rates for single-story residential construction in Kelantan. Using this method, the total construction cost is calculated as 170.78 meters square times 942 ringgit meter square equal to 160,884.76 ringgit. The value is rounded to 161,000 ringgit for presentation purpose and early stage reporting. This estimate is considered realistic and defensible as it is grounded in actual design specification and verified local construction costs. It enables stakeholders to begin financial planning and loan application to establish cost limits before the tendering process and to benchmark against similar housing development costs in the area.
Next is reliability of the estimate. The construction cost estimate of 161,000 ringgit for the purpose single-story bungalow is considered reliable at the early stage of the project. This is due to several supporting factors. The estimate is based on precise floor area dimensions taken directly from the architectural drawing and a unit rate of RM 942 per square meter that reflect current construction costs in Kelantan. The rate includes all major cost components such as substructures, superstructures, roofing finishes, services, and preliminaries. A small buffer is also included to account for general uncertainties for the purpose of budgeting, feasibility, and financial planning. This estimate provides a solid and defendable cost reference. However, as a method based on generalized rates, it still carries a margin of variation that depends on external conditions. Despite the reliability of the stage, several influencing factors may affect the accuracy of the estimate as the project progresses. Location plays a major role. Construction rates in Kelantan are generally lower than in urban areas, improving cost uncertainty. However, any logistical issues due to rural access could affect transport costs. Inflation is another factor. If the project is delayed, the cost of materials and labours may increase, pushing the total project cost beyond the estimate. Material prices, especially for cement, steel, and roofing materials, are volatile, so the market shift can significantly impact the cost per square meter. Next is labour availability may affect both cost and schedule. A shortage of skilled workers or rising wages could increase the final cost of construction. After that is weather condition, particularly during the monsoon season in Kelantan, could delay work and increase site overhead costs. Lastly, design revision can invalidate the current estimate. Any changes in layout, finishes, or structural system may require recalculation and adjustment to the unit rate.
Conclusion and recommendation. In conclusion, the application of the floor area method in this project successfully provide a clear, structured, and realistic early-stage cost estimate for the purpose one-story bungalow in Kutong, Limbat, Kota Baru. By using accurate measurements from architectural drawings and a breakdown of construction cost components tailored to Kelantan market condition, the estimated project cost was calculated at 161,000 ringgit. This method proved to be efficient, reliable, and suitable for the current development phase, offering essential insight for budget planning and early decision-making. Overall, this exercise has demonstrated the practicality and importance of approximate estimating in the building economics process. For the recommendation, although the floor area method provides a strong starting point, several actions can be taken to improve the accuracy of approximate estimates throughout the project lifecycle. First, it is essential to use up-to-date local data. Construction rates should be regularly updated based on current prices in project location. For example, using cost data from CIDB, JKR, or recent standard submission in Kelantan. Second, every estimate should incorporate contingency buffers, typically between 5 to 10%. This allows room for inflation, weather-related delays, or minor design adjustment, helping to avoid underestimation. Third, design measurements must be verified directly from scaled architectural drawings. Relying on assumption or approximation can introduce errors early in the budgeting process. Fourth, whenever possible, the estimate should be broken down elementally, even if using the floor area method. Assigning values to specific building elements like roofing or foundation reduces uncertainty and highlights cost drivers. Fifth, it is important to monitor market volatility. Prices of materials such as cement, steel, tiles, and fuels should be tracked regularly to ensure rates remain relevant throughout the planning phase. 6. A site-specific risk assessment should be conducted. Conditions such as soil type, site accessibility, and regional climate, especially monsoon impacts in Kelantan, can all affect construction costs, particularly for preliminaries and external works. Lastly, estimates should be updated at every major design milestone. Transition from approximate methods toward more detailed techniques as the design evolves from preliminary planning to the tender documentation.